The next session is going to be a audio presentation by Bala, who couldn't be here because of his various practical difficulties to travel. So with that, I'll hand over the mic to Sundar, who will give a brief introduction about this talk, since Bala can't be here.
Okay, this is not an introduction, it's just a disclaimer. Okay, the disclaimer is because I didn't know what Bala was going to do, and he couldn't come for various reasons, and then he sent this. I haven't seen it. Arun saw it, and I know Bala has been trying to engage with the work which I was mentioning the other day, my book Indian Philosophy and Philosophy of Science. So the first disclaimer is I had nothing to do with the asking him to speak on my work or on his criticism. I mean, he's also, I think, drawing a lot, but he's also critiquing it. And I actually had no, because some people might think because we're the organizers, we are forcing speakers to read our stuff. So, no, but there's also, why I also came to say this is because we've been struggling with the question of what is it to make sense of history and philosophy of science in the non-European context. It's okay to say, this question I think which you also raised that day, it's okay to say it's European in origin and Indians contributed and so on. So the aim of this, this work was actually to show how the questions of Indian logic actually mimic certain characteristics of what has been called a scientific methodology, and from that, what can we really learn about the relationship between logic and science if viewed from different perspectives. So I think it's something which can be critiqued on many grounds, and I think Bala is doing one of them. And we will have a discussion on it because also a critique of quantum logic and stuff, which Gordon can say something more after the thing, and maybe Roland and others can pitch in. So we will have this as a session, and then we will have a discussion around it later on, if not immediately following this bit later.
Hello everyone. I trust the summer school is proceeding well. I'm sorry I cannot be there in person to participate in this exciting event. However, I'm really glad that I can do this indirectly, given the miracle of digital technology. The subject of my lecture is Indian philosophy, or actually Indian logic, scientific, exploring cosmopolitan frontiers. Now, the lecture I'm doing is based on 3 readings that were assigned to you. The first by Sundar Sarukkai, from the chapter Science and Logic, the Indian Way, which is chapter 5 in his book Indian Philosophy and the Philosophy of Science. The second reading is by Mario D'Amato, entitled Buddhist Fictionalism, in the journal Sophia. And the third is a reading by me explaining strange parallels, the case of quantum mechanics and Madhyamika Buddhism, which I published some time ago. I trust you have them and also possibly have had a chance to read through them. You may have wondered about the connections between these papers, and this lecture will be an attempt to show what they are and why it is relevant to answer the question, is Indian logic scientific? In fact, the lecture is basically an attempt to develop further the thesis proposed by Sundar Sarukkai that Indian logic has the structure of a scientific theory, rather than the structure of a formal system as is Western logic. However, Sarukkai only considers the structure of Nyaya logic to make his case. In this lecture, we will attempt to see if the very different Indian logic of the Buddhist Catuskoti, or rather it should be pronounced Catuskoti, also has the structure of a scientific theory because it is grounded in experience, and why it is an uncanny affinity for the philosophical interpretation of the quantum theory. This has actually not gone unnoticed by some of the founding scientists of the quantum theory. Indeed, in a recent paper, Juan Miguel Marin, the paper is entitled Mysticism in Quantum Mechanics, The Forgotten Controversy, published in the European Journal of Physics, discusses this issue in great detail if you are interested in exploring it further from a historical point of view. However, before I proceed with the central concern of this lecture, let me say something broadly about the theme of this workshop: digital cosmopolitanism and scientific realism. At first, I could not see the link between digital cosmopolitanism and scientific realism. A search on the internet led me to Ethan Zuckerman's book, Digital Cosmopolitans: Why We Think the Internet Connects Us, Why It Doesn't, and How to Rewire It. Zuckerman is an American media scholar, an internet activist, and also the director of the MIT Center for Civic Media. His book was published at the end of 2014, less than a year ago, but is really a second edition of an earlier book published in 2013, but under a different title: Rewire: Digital Cosmopolitans in the Age of Connections. Zuckerman looks at the strange paradox of the internet, which offers the possibility of global cosmopolitan connections, multicultural, plural, international, diverse, while at the same time promotes in fact connections that are provincial, parochial, local, regional, and even ethnic centered. His conclusions are based on numerous studies of Facebook connectivity, newspaper article focus, internet search data, and so on. There are more niche markets for narrowly directed communities defined by ethnic and religious and other identities than he actually finds even in the age before the internet. Internet search engines now even use information based on our history of searches to take us into search outcomes tailored to fit our past search interests, thereby increasingly moving us from the global to the parochial. Zuckerman attributes this narrowing of focus to the phenomenon of homophily, the love of the similar. For philosophers of science, the notion of homophily may be familiar in the idea of normal science as defined by Thomas Kuhn. This is the tendency of scientists to work within a paradigm and to be reluctant to move in directions that put into question either the principles, norms, or perceptual expectations induced by the paradigm. But Zuckerman also notes that experimental surveys show that the individuals who come up with the most creative ideas are often cosmopolitans and not the provincials. They are those who cross the boundaries of culture, nation, religion, and so on. Multi-perspectivism seems to nurture creativity. Hence, his book is about how to rewire the internet to realize its potential for greater connectivity, to foster greater creativity. It is about how to build features of what we might say are Kuhnian revolutionary science into the internet rather than separate spaces of Kuhnian normal science, so to speak. However, we must not imagine that cosmopolitan connections have only been made possible by the digital world of the internet. In the period from 500 to 1500, the millennium before the modern era, vast trading linkages were created between the various major Eurasian civilizations, the Indian, Chinese, Arabic, and Western, among others. These were linkages along which great medieval travelers like the Chinese Xuanzang, the Indian Bodhidharma, the Moroccan Ibn Battuta, and the Italian Marco Polo crossed civilizational divides. The networks also led to great exchanges of scientific knowledge. We know that it was in this era that Al-Biruni made his famous study of Indian scientific traditions and contrasted them with those of the Greeks in the 11th century. At about the same time, Said al-Andalusi was writing of the scientific contributions of the Greeks, Arabs, Chinese, Chaldeans, and Indians, among others, in the West, in Andalusia, now Spain. Although we must admit that he was quite ignorant of Chinese achievements because he did not hold them in high regard. But China was very far in the east from Andalusia in the extreme west of Eurasia. However, despite these exchanges, the different scientific traditions in the various civilizations did not coalesce into one tradition. This diversity within cosmopolitan connections across civilizations actually creates interesting issues for us today for understanding what we mean by scientific realism. Let me illustrate this point with astronomy. Today, when we look east and see sunrise, we think that this is an illusion. We are taught that the sun is not really rising, but that it is the horizon which is falling due to the rotation of the earth. The heliocentric theory, we now believe, requires us to see not only the earth as revolving on its axis, creating the illusion of a rising sun, sunrise, but also the earth is orbiting the sun approximately every 365 days. However, this was not the belief of pre-modern civilizations. In the millennium 500 to 1500, before the modern era, there were three major paradigms in astronomy, if we may call them that, paradigms of heavenly motion. The Greco-Arabic tradition in the far west saw the heavenly bodies as moving around the earth. This is geocentrism. The Chinese in the far east saw the heavenly bodies as rotating around the pole star. We now see it as an illusion created by the rotating earth. This is pole star or polar centrism. On the other hand, the Indians saw the planets, the ones that are visible to the naked eye, such as Mercury, Venus, Mars, Jupiter, and Saturn. Of course, they knew them under different names, as revolving around the sun, and the sun as revolving around the earth. This is actually a geoheliocentrism, a view that Tycho Brahe was to propose in Europe in the 16th century, as a kind of a via media between geocentrism, the ancient theory held by Ptolemy, and heliocentrism, the new theory proposed by Copernicus. But all of these different cosmopolitan perspectives on science and the heavens creates particularly disturbing problems for both the logic of science and for our understanding of scientific realism. It creates problems for the logic of science because science can no longer take the evidence of the senses for granted to begin scientific theorizing, even though such theorizing has to begin with some evidence or other from the senses. All these different cultures, the Greco-Arabic, the Indian, the Chinese, use the same evidence from the senses by looking at the same heavens above to experience seeing quite different kinds of heavenly motion. It creates problems for scientific realism, as you can understand, because each of them considered they were seeing real heavenly motions. But we think today that what they saw were all illusions, what we might call convenient fictions that help them to make predictions of motions of heavenly bodies, but not the real thing. Clearly, adopting a cosmopolitan approach to science, in this case astronomy as an example, raises intriguing questions both for our understanding of the logic of science and the nature of scientific realism. However, these three Eurasian traditions were important for the birth of modern science. This is because at the time of the scientific revolution in the 17th century, modern science was able to draw upon their thematic, theoretical, and technical resources in reconstructing the world in the heliocentric framework we accept today. Although it remains a controversial issue, many dialogical historians of science have argued that cosmopolitan exchanges between the different astronomical traditions of Eurasia were crucial for the emergence of modern science. We also know that philosophy in the past, as with science, has also benefited from cosmopolitan exchanges. The revolution in Chinese philosophy, which came with the Neo-Confucian turn in the 11th century, was shaped by the impact of Buddhism from India. Arabic debates between the falsafa schools inspired by Greek thought and Kalam traditions, which some see as derived from Indian influences, also can be seen as shaped by cultural traditions of philosophy from different parts of the Eurasian region. And ancient Indian and Greek traditions of philosophy influence each other, although the connection through the connections established by the Persian Empire and the post-Alexandrian Indo-Greek Buddhist kingdoms. This raises the question of whether contemporary philosophy, especially philosophy of science, can also engage in fruitful dialogue with Eurasian traditions outside the West in which modern science first emerged. And this brings me to Sundar Sarukai's study. In his book, Indian Philosophy and Philosophy of Science, Sarukai explores the possibility of drawing upon Indian philosophical traditions, particularly its rationalistic ones, as he puts it, to understand the nature and foundations of science. Sarukai examines a number of reasons why Indian philosophy has hitherto not been seen as relevant for philosophy of science. In the first place, modern science developed in the West. Therefore, it is assumed that traditions beyond the West cannot illuminate philosophy of science. Only Greek philosophy can be relevant to science. Sarkai refers to this as the originary issue for philosophy of science. He argues that this perception of the irrelevance of Indian philosophy for philosophy of science is also reinforced by the prevalent assumption that natural science grew out of philosophy. In fact, Sarkai rejects these arguments. He notes that not only did science break away from ancient Greek philosophy, but also ancient Greek science itself. It is paradoxical, he points out, that there are those who see contemporary philosophy of science as based on insights from an ancient tradition whose rejection was the precondition for the emergence of modern science. Secondly, even if we take Indian philosophy not to have any kinship with modern science by way of civilizational origins, there are conceptual and methodological issues addressed in the Indian rationalist traditions that can illuminate modern science. These include, as Sarkai notes, notions such as inference, reasoning, knowledge, causality, and many others, which are philosophical themes common to Indian and modern Western traditions. Hence, there is no reason to suppose that Indian philosophy cannot be a resource for philosophy of science. Moreover, it is not the case that Indian philosophy did not have any impact on modern science. One of the most characteristic features of modern science is the emphasis of the role of mathematics in the formulation of theories in areas as diverse as astronomy, physics, and even molecular biology. Here, the power of mathematics is closely linked to the number system, the decimal place value number system with 0 that we use today. This system was first developed in India. It is the number system that made possible the great development of algebra, infinite series expansions of trigonometry and circular functions, as well as ideas of the calculus in both India and early modern Europe, so crucial to the scientific revolution of the 17th century. Hence, some scientists and historians of science, for example, Rodham Narasimha in India, see modern mathematics as the outcome of the fusion of Greek geometric and Indian number theoretic ideas. Such a view also gives us grounds to suppose that Indian philosophy, which laid the originary basis for the Indian number system, can be relevant for modern philosophy of science. Now, Sarkai also addresses the perception that Indian civilization was basically hieratic. That is, it was a priestly culture and therefore largely concerned with religious philosophy, which can have no relevance for the philosophy of science. He rejects such a view for two reasons. Firstly, he says that there already exists a number of rational traditions in Indian philosophy that are not simply theologically motivated. And second, he also notes that there was a lively and vibrant scientific and technological culture in ancient India. both of which, of course, cannot be denied. But I think to what Sarkai says, we may also add a third reason, one emphasized by the Japanese comparative philosopher and historian Hajime Nakamura in his study Parallel Developments. Nakamura writes, in the West, the two terms, that is religion and philosophy, have been fairly sharply distinguished from each other, while in Eastern traditions, the dividing line is often difficult to discern. If we insist on being too strict in our definitions, we fail to catch many common problems. It is possible that an idea or attribute held by a Western philosopher finds its counterpart not in an Eastern philosopher, but in an Eastern religious thinker, and vice versa. Indeed, this being the case, there are no grounds for repudiating appeal to Indian thinkers who make their case on philosophical grounds that are rational, even if they are motivated by religious concerns. After all, even Western thinkers like Descartes, Leibniz, Kant made seminal contributions to the philosophy of science, even though their motivations for addressing such issues had also been grounded in their religious beliefs. Although Sarakai's book addresses many possible conceptual links between Indian philosophy and philosophy of science, I would like to look closely at one of the most controversial claims he makes, namely that there is a fundamental difference between the way logic and science relate to each other in the Indian and Western traditions. He describes this difference as follows, and I quote him. It is this question of priority, whether logic comes first or science, that is at the heart of the difference between Indian and Western logic. A difference that is characterized by the question, should logic be scientific or should science be logical? If by scientific we mean both an empirical and theoretical mode of reflection, then logic is not scientific. For Western logic, since the essential character of logic, well, it's not scientific for Western logic, since the essential character of logic is to be outside the domains of the empirical in an explicit manner. Thus, for Western and modern logic, the issue can only be of the logical in science. In contrast, for Indian logic, it seems that the central concern was to make logic scientific. This implies that logical statements have to respond to empirical concerns. While this move militates against the very notion of logic in the Western tradition, it is precisely this demand on logic that makes Indian logic essentially correlated to scientific methodology. Unquote. The contrast between the Western and Indian views of logic can be illustrated by looking at the difference between the Greek Aristotelian syllogism and Indian Nyaya inference. An archetypal example of Greek logic is the following argument. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. What is important about this argument is its purely formal structure and its emptiness of empirical content for it to be valid. It is formal because we do not need to know the meaning of the term Socrates, man or mortal, to know that the conclusion must be true if the premises are true. Secondly, it is empty of empirical content because the truth of the premises is not required for the conclusion to follow from the premises. For example, I may be using Socrates to refer to my cat, thereby making the second premise false, but it does not make the argument invalid. The valid form of the argument can be contrasted with another argument that is invalid. Take the following. All men are mortal. Socrates is mortal. Therefore, Socrates is a man. Here the conclusion can be false even if the premises are true. This would be the case if Socrates is a cat. If Socrates is a cat, he would be mortal, but not a man. So the truth of the conclusion does not follow from the truth of the premises, since the premises can be true and the conclusion false. It is clear that the validity or invalidity of an argument is not determined by the truth of the premises or that of the conclusion, but by the form of the argument. On the other hand, if one were to treat the inference as making a claim about the real world, namely that all males of the human race will die, and that Socrates is a male human and therefore will die, the truth of the conclusion would only follow if the premises were also true. Establishing the premises as true would require making careful observations to arrive at the generalization, all men are mortal, and we would have to check by observation that Socrates is indeed a man. If both these premises are true, we would then say the argument is sound. A sound argument is one which is formally, that is logically valid, and also has premises which are true. Western logic is the attempt to establish the structure of formally valid arguments, and Western science can be seen as an attempt to discover general principles that have been confirmed as true, to be used in conjunction with logic, to offer explanations or predictions of phenomena in the world. The soundness of scientific theorizing is seen as dependent on logic. Indeed, it is required to conform to logical form. In this sense, Sarkai would say that in the West, the logic is in the science. However, he would also add that the science is not in the logic. For the validity of a logical argument does not depend upon any truth or falsity about claims concerning the physical world. The laws that regulate logical inferences are independent of the laws that regulate the physical world. Indeed, laws of logic are seen within Western philosophy as applicable to all possible worlds. Sarkai characterizes Indian philosophy as founded on quite different relationships between science and logic. He argues that contrary to the Western view that logic is in science, Indian thinkers take science to be in logic. This means that they treat logic not as involving a formal structure of reasoning, but as exhibiting a scientific structure of reasoning. He attempts to demonstrate this by looking at the structure of Nyaya logic. Nyaya inference involves a combination of induction and deduction that moves from particular to particular via the general. The argument has 5 steps, as illustrated in the example shown. First, there is the proposition, there is fire on the hill. Next, the reason, for there is smoke. Example, to illustrate a general premise, Wherever there is smoke, there is fire, as in the kitchen. Application: this is such a case of smoke on the hill. Conclusion: therefore it is so, that is, there is fire on the hill. Sarukkai argues that Nyaya logic has the structure of the deductive-nomological model of explanation, or the DN model, proposed by Hempel. This model takes explanation to be a deductive argument from premises, including one or more general laws, discovered by observation and experiment. As an example of the DN model, he gives the following: all Bunsen flames turn yellow when sodium compounds are placed in them. All rock salt consists of a sodium compound. A piece of rock salt was placed in this Bunsen flame at a particular time. This Bunsen flame turned yellow at that time. Sarukkai notes that for this inference or explanation to be good, 4 conditions must be met. The explanation must be a deductive argument. The premises of the explanation must contain at least one general law actually needed in the deduction. The premises must be empirically testable. The sentences in the premises must be true. And gestalts are shaped by the conceptual context through which we make observations. Though this makes them separate kinds of phenomena, they exhibit a similar structure of logic, one that seems to violate standard logic, which is based on everyday experience, so our experience of everyday objects. I realize the claims I am making here are controversial, and Sarukkai himself rightly cautions us against linking Indian philosophy with the quantum theory. Indeed, he explicitly repudiates attempts to link the two, and I quote him. This is on the first page of his book. The claim that some concepts in modern science, particularly in quantum theory and cosmology, are described by and anticipated in ancient Indian thought This is not only a contentious claim, but also one that is untenable or even undesirable. Modern science, particularly quantum theory, is a discourse which is unique in many respects, and to claim that some elements of it are actually what the Indian thinkers were thinking about is to mistake the nature of both Indian philosophy and modern science. So, having mentioned this cautionary tale, let me end by saying that this lecture has stressed 3 points. Firstly, the Indian logic of the Catuskoti, based on meditation-induced experience, has a different structure from Nyaya and Aristotelian logic. Secondly, this difference is germane to Sarukkai's thesis that Indian logic is empirical. And finally, the logic of the Catuskoti has parallels to the logical structure of quantum properties. Hence, my answer to the question, is Indian logic scientific? And I put Indian in brackets, requires accounting for the 2 different structures of logic and experience addressed in Indian philosophy. The fact that there are 2 structures based on 2 different orders of experience One, the everyday experience of the world of common objects, and the other, the meditation-induced experience of the Gestalt-like nature of all perceived objects, suggests that Sarukai's claim that Indian logic is scientific and experience-based is correct. One may also add that it suggests that all logic is experience-based, except that Western logic is based on the reified, conceptually constructed experience of the everyday world. This, I think, gives us food for thought. What does it mean for philosophy of science? I will end here with this question.